Explain what would happen if in the capacitor given in exercise 8 a 3 mm thick mica sheet of dielectric constant 6 were inserted between the plates. In two cases, first one is while the voltage supply remained constant, and second one is after the supply was disconnected. Our motive is, from the previous problem we have a capacitor which is having air as medium between those two plates, but now we are keeping a dielectric material having dielectric constant K. Here we have been given two cases. In one case we are keeping the old potential with the capacitor, and in second case we are removing this potential and we are just remaining this capacitor as it is, and in these two cases we are keeping the dielectric material. So at that moment we need to find out the things which are going to happen. Now come to the investigation part from the previous problem. When the air is as a dielectric medium, the capacitance C is equal to 18 into 10 to the power of minus 12 farads and V is equal to 100 volts, and the charge deposited on that capacitor Q is equal to 18 into 10 to the power of minus 9 coulomb. Now come to the resolving part. I am going to resolve the first one. So C dash is equal to, because we have kept a dielectric material between those two plates, that new capacitance achieved by the capacitor can be written as C dash, that is equal to K into C, that is equal to 6 into 18 into 10 to the power of minus 12 farads. It is equal to 108 into 10 to the power of minus 12 farads. So this much capacitance it will attain after putting dielectric material between the plates. Now the new charge that is deposited on the capacitor can be written as Q dash is equal to C dash V, that is equal to 108 into 10 to the power of minus 12 into 100, that is equal to 108 into 10 to the power of minus 10 coulomb. This is the first case. Now come to the second case. In this case we have removed the cell which is connected to this capacitor, and we have added a dielectric material for this capacitor. So at that moment there is no chance to leave the charge from this capacitor. So Q doesn't change. Q is equal to 18 into 10 to the power of minus 9 coulomb. By keeping the dielectric material, we are increasing the capacitance, that is C dash is equal to 108 into 10 to the power of minus 12 farads. Due to this, the potential difference between these two ends will changes, that is equal to V dash is equal to Q by C dash, that is equal to 18 into 10 to the power of minus 9 divided by 108 into 10 to the power of minus 12. 18 ones, 18 sixes. So you will get 1 by 6 into 10 to the power of minus 3, that is equal to 16.6 volts.